Testing, testing.
Okay, sounds good.
Make sure you give me consent to record this.
Yes. You have.
Okay. I think the stream should be live. There may be like a 30-second lag in the YouTube, but hopefully folks will let us know that they can hear us. So hello world. I am Lane, aka Naplet Hildeck, and I'm very excited to introduce the third in the series of Urbit developer calls and to welcome everyone to the call. So thank you for joining. I'm very thankful to Josh and the Urbit.org Foundation team for making this event series possible. I will hand it over to Josh in a moment to introduce the grants program and Urbit.org and then introduce today's speaker, timluc-miptev. So by way of background for folks who haven't joined a previous call, this is a community-led initiative and it started out as a grant application. And the motivation for the event series is to sort of capture the sort of cultural information that tends to be missing from existing documentation, technical as well as cultural knowledge. And as I said, it's a community initiative. So if you are interested in contributing to future events, whether these roughly biweekly developer calls or some of the larger events that we have coming up, like a town hall, please do reach out. There is an event series discussion chat channel inside Urbit community. And so you can also join that now or chat on the YouTube chat box. And we can make sure that questions you ask, we can refer them to Tim to answer. All right, someone said they can hear us. That's a good sign. So this event and all the future events and the past events as well will all be recorded and posted on urbit.org. So no worries if you, I guess, are watching a recording instead of tuning in live. Pretty straightforward. We're going to hand things over to Tim in a moment, and he's going to tell you all about the awesome and really exciting work that he's been doing integrating Bitcoin into Urbit. I'm personally very excited about this project. Had like a sneak peek of it a couple days ago, and I think everyone else will be really happy to hear about the work as well, because it's very important, integrating two important ecosystems and religions, which hopefully we'll have a chance to talk about later. We'll leave plenty of time for Q&A, so if you have questions, you can begin posting them anytime in either of those channels in YouTube or on the event series discussion channel in Urbit community. And then just as a reminder, at the top of the hour, we will turn off the recording, turn off the stream, and we'll transition to like a happy hour social format. So stick around. We'll at that point, we'll share the link to invite everyone to go ahead and join this call if they want to hang out and have a drink handy, I guess. So, all right, without further ado, I'm going to turn things over to Josh to talk a little bit more about urbit.org and then introduce Tim.
Sounds good. All right, thank you, Lane. Yeah, so this project, actually this developer call is really exciting because, as Lane mentioned, these developer calls are a proposal, a community-led initiative, and Tim is a developer working also on a grant. So we have a grant through which we're viewing this about a grant that's being done, which is kind of cool. When I came on to do this foundation work, kind of the first task I was given was figure out Bitcoin. The work was originally started on this over a year ago, and Norsar Torin, also known as Jose, has done a bunch of work on this. He worked on the RPC APIs for many months, worked on BIP32 integration, got a PR up that, and both of these PRs were, they took about a year to get merged, and they actually only just finally got what was needed to merge as of the breach a couple days ago. So this has been a long running thing. And so I kind of jumped in figuring out where we were and how Bitcoin would work with Urbit and what we could actually build on this, and devised a spec and actually turned it over to Tim for feedback, who was one of the more prolific community developers that had been working with Gall and teaching us all how it worked. And I was actually just expecting him to kind of give me some feedback on the architecture, and he said, actually, no, I want to do this. It's like, great, that's awesome. So Tim and I have been meeting every week for the last few months as he's been working through this, and he's done an absolutely awesome job on this. It's very nearly complete. And along the way, there's been a lot of learnings about how something external to Urbit like Bitcoin, which is externally running infrastructure, would get integrated with Urbit. And there's a whole bunch of cool patterns that have emerged from this that he's going to kind of go into. So I will turn it over to him, and he's got a lot to talk about. And Lane and I will sign off on our videos, and we'll jump back in if needed. So Tim, take it away.
All right, thanks a lot, Josh. And I'll probably be switching off video in a sec and going into presentation mode just to, get through this pretty efficiently because there's a lot to hit here. So let's actually just get that started. Let me share the screen. Here we go. All right. Hopefully that's good. Josh, Lane, if there's any issues along the way, just let me know. Okay. All right, awesome. Hopefully the presentation looks good too. So yeah, we're talking about like injecting external services into Urbit. Josh already gave the background here about like how this has been going on for a while. With the subtext here, there is no they. Mainly that like one of the big reasons I wanted to do this is that I'm fairly passionate about Bitcoin in general, and there's no sort of in Urbit if you just sort of wait for stuff to happen that's not part of the like sort of very core experience. It doesn't, but conversely, if you're willing to just like sort of get in, learn Hoon, and start writing stuff, you can actually get pretty far pretty quickly. And there's a few other devs in the community doing similar stuff. So the idea of this project is that, on the one hand, Bitcoin's meant to be run on your own, but that's hard to do. So ideally, there would be a way to have providers run it for you, but without, ones that you trust. But also, there's a lot about the Bitcoin experience that has a fair amount of friction. Just if I, outline the process of I want to pay someone, that involves them ideally generating a new address that they haven't used before, communicating that to me in some way. And even if it's fairly efficient, like them cutting and pasting into a chat, that's still a human doing a lot of work that a computer should be doing. So this isn't just about like letting people run Bitcoin on their own because, for some religious reason, although I do really appreciate the kind of like quasi-religious fervor with which Bitcoiners, want to be able to run their own nodes. And I've kind of absorbed a lot of that in the course of this. But it's also about like, okay, how can we use Urbit's unique properties to like make the Bitcoin experience even better? Oh, wow, without sacrificing ideally things like, privacy or verifying the chain or things like that. So that was like, the focus going into this project. And the main reason I was excited about it, in addition to just it being Bitcoin, is that I'm just really passionate about Urbit's properties that it has and the things you can do, especially in like peer-to-peer networking, and how much there's like batteries included in that regard, which we'll see later in this talk. So personal background, I'm timluc-miptev. My name is also Tim. So there's not that many at P's that also, let you do that. So that was nice. I guess you can call me a community developer, although this is the first really even moderately substantial project that I've done in Hoon, which I think should definitely encourage people who are wondering, what the learning curve there is. I started in May-ish writing the knock guide and then the gall guide through the summer, which was a lot of poking around in how user space apps work, but without actually, writing a big one. So that gives you like kind of an idea of the timeline that it takes to be able to do decent stuff here. It's really not very long and probably a lot faster now. I run a few different like private groups. If you're in them, you know what they are, and I spam public groups heavily. I'm probably one of Urbit's most active users, definitely in the top 3 or 4. Anything else there, Lane, or should we keep going? Um, yeah, why not? Let's see. There we go. I'm kind of against like slides in general, so I barely even know how to use them. Okay. So here's like the goals of this project, because I'm going to demo it later on here in a bit, and it's good to kind of have a framework for what we were trying to achieve. The main goal is to add like payment primitives to Urbit that can then be recombined and expanded on. So ship-to-ship payments. A big goal of it is like abstracting away Bitcoin addresses, like I just mentioned. So anytime you have to like request an address from someone, then manually choose which of put that into your wallet and make the transaction. If you can automate that step, you're saving a factor of like probably like 1,000 in terms of how much time is saved. Somewhere around there. So Urbit makes that really good because if each Urbit ship has its wallet stored, especially maybe a watch only wallet, you can just do ship to ship payments where your ship pings another ship and says, "Hey, I want to pay you." And as long as that ship is cool with it, they automatically generate and send back to you an address, and you automatically generate a payment. And the only manual step at that point is just approving the signing, for which there's a couple different possible flows. But the other even bigger thing, and I think that's already pretty cool, is that once you have ship-to-ship payments, and I tell, like, Woolref Podlex that my ship tells him that I want to pay him, and then later his ship observes that amount of money happening, he can attribute that to me in his local database, in his local Urbit. And at that point, you have like Urbit native payment receipts, which are going to be programmable. Other, programs you have running on your Urbit can query them and see, you know, did timluc-miptev pay me like X amount of money? And at that point, you can like very easily do content unlocking or like access automation, or like even it would be like fairly easy to do member only groups or forums or things like that. So you're already eating into a big chunk of like Substack, WordPress, like Patreon type stuff, which I think is really cool and necessary for this to expand. The way I say it at the end here is, Urbit's for communities, and communities need payment rails. And that's not really a hypothetical thing. Again, with those services I mentioned, we see that all the time in the current internet. A really big focus here is to support Bitcoin best practices, like, not reusing addresses, for example, and also maintain upgrade paths to improve privacy. We'll see right now that the provider probably has access to a little bit too much information in terms of which addresses you transact with, but the design decisions made make it possible to upgrade that in the future. And also, the easiest way to upgrade that right now, if you have, like, let's say you start transacting a lot and you don't want your provider to know how much you're transacting, you can run the full node yourself. It's drop in, and we'll see in the demo that if you have the full node running on your computer, adding this program in to your, have your Urbit access it is a matter of like literally just, 2 lines or instructions. As mentioned earlier, there has been like substantial work that's gone into this already. So I'm not sure why I was saying here that seed combines with indices, but I'll give that background. So as like Josh mentioned, he did the design in the summer that I'm working off of for the most part and modifying. Norsire Toiren did the RPC work, which is basically how your ship can send commands to Bitcoin. And then also BIP32 and ECC work. The long and short of that is he made a lot of the kind of ground level functions that are necessary just to generate addresses and talk to Bitcoin, and that was really helpful. Christian Langalis, Pindet, did like a great has just been really great, like introducing me to people in the Bitcoin community who can help with development. And Piri Kovanen has some nice stuff going that we're going to use where your Urbit wallet can automatically generate a Bitcoin wallet now. And so that'll be like, we'll be putting that up pretty soon in the community. Let me actually, okay. One other thing just to sort of have in mind throughout this talk, which isn't going to get too technical on the Bitcoin side unless people want, but just for background, whenever we talk about like seeds or XPubs, essentially Bitcoin lets you create these like, long strings of text, and based on them, you can deterministically generate billions of addresses. So, and that information also is moderately sensitive in that if people know it, they can like find out how much money you have, but it can't be used to steal your funds. And so it's like not insecure to put it into your Urbit. So what that means in practice is that you can basically take a wallet that you have, get the public facing part of it and import it into Urbit, and it will just work. And I'll demo that a bit later on. All right, so let's get into the architecture that we used. In terms of, let's think of this from the perspective of what do you need to do if you want to run a provider who basically provides access to the Bitcoin network to people inside Urbit, and what you want to do, what you need to do if you're a client. So if you're a provider, there's a few external services you need to run. You need to run a Bitcoin full node, which takes like a day or two to sync up and is about right now maybe 350 gigs of data, give or take. You need to run an electrs node for address indexing because Bitcoin core doesn't let you say, here's an address, tell me how much balance it has. So we needed to add that so that providers don't have to store your wallet. And then you need to run a Gall agent called the BTC provider. And that's just a matter of, in the usual way, starting it up with the start command in Urbit after you've copied the code. So from the provider side, the most burdensome parts of that are getting the full node synced. In terms of like actually running it, there's some like pretty simple scripts you can do. So that's straightforward, and we'll go over that later in the call. And then the Gall agent is like very straightforward. Now, here's the really cool thing. Once you have that, you can provide access to clients to use it. And when I say provide access, all that means is you can say, okay, whitelist these ships and just let them, query the Bitcoin blockchain through me. Or, eventually, it would be probably just an hour or two of work. You can say things like, let everyone in this group, hour or two of work for me programming, I mean. You can say things like, let everyone in this group access me as a provider, and do those kinds of things. Is extremely straightforward. Then you need to run those wallet agents, which is a quick install that we'll see later. You need to have an xpub, this like seed that can generate your public addresses. You can get those pretty easily from like, well, we can generate it right now from your Urbit ID. You can get it from a hardware wallet easily, from like a software wallet. And the key point here that we're going to explore is that this is fully Urbit native from the perspective of the client. So the client is just subscribing to a provider, but the client doesn't know or care that the provider is getting its information, from outside of Urbit. It's able to ingest all of it in sort of a safe, Urbit-y way, where it can make all of the usual assumptions about how networking works inside of Urbit. And the best thing I can say about that, we'll see it later, is that once I kind of finished writing that part, I haven't really thought about it since. Urbit's networking primitives are really, really good. And once you kind of package things up to inject that provider into the system and provide access to it, you can treat things just as very sort of normal Urbit programming, much like writing like, a chat program in Urbit or something like that. Before I keep going, anything on your end, Lane, or should I like keep rocking through here? Oh yeah, that's like Wolfgang, like Wolfie. And yeah, he's extremely friendly. He's a very sexual erotic dog. So he spends a lot of his time trying to achieve fulfillment in that regard, and just really likes people. I've been like very hesitant to castrate him for like the usual reasons that people don't like to do to their dogs. So Woofy, he's like, yeah, he has food over there, so he's not interested in other stuff.
The presentation's awesome. So yeah, keep up the good work. Everything is super clear.
Okay. Yeah. So and let's see. Let me go back. Let me just hit this. So I'll bring him on like a little bit later. He's interested in the video medium. Okay. So architectural decisions and trade-offs. So a big thing here, when I say where to draw the abstraction barrier, there's a choice in a lot of this. Like just imagine if you have let me think of an example here. Let's say you have the information that packaged up could form a Bitcoin transaction, meaning you have like the inputs going into the transaction and the outputs. And you have to make a decision as to like, should I kind of slam all this together in hex inside Urbit? Or should I throw the information outside and use like pre-existing functionality and get it back? And so this is like basically what computation needs to happen inside your Urbit and what can you throw out there. So a lot of the architecture is basically my trade-off. Can I get this? I'm probably a little loud in the background. It's basically a trade-off between speed in terms of like how to get this out there, and then privacy, where anything that could potentially be like a privacy issue, I've tried to handle inside Urbit. So we can look practically at how that goes. And I think the easiest way is to look at the provider components and how we use them. So there's the Bitcoin full node, pretty straightforward. That just has the current state of the blockchain since the beginning of time. Elect-RS, which is a Rust program that provides address indexing so that you can give a Bitcoin address and say, tell me the balance of this address right now, which you can't do actually just through the standard Bitcoin program. So it layers on top of it. And then we have a proxy. The proxy is like a fairly simple node program that I initially wrote because elect-RS does not have an HTTP interface. So and Urbit can only talk to outside services that are HTTP. It can't just send random TCP calls. So I had to write it initially for that. But then there's also this thing where you very, very often, and I'm actually gonna just jump out to that and show, Lane, is this visible? Are we seeing everything well?
Yeah, that looks good to me.
Okay. I could, and I will. Here we go. So here's an example of what that simple node proxy looks like. And this is an example of it exposes an API endpoint to Urbit where you can say, just give me info about this address. And the key thing here is that involves chaining a couple different calls together. One to get all the unspent transactions, another to get the full history, including spent transactions, another to get the current block count, and another to get the current time. So inside Urbit, there's two ways to handle that. One is you could just throw all those calls out to the outside world, maybe with some ID. And then when they come back to you, key off that ID and package them up together. This is definitely a lot faster and simpler for development. You can just throw together some JavaScript promises. Now there are ways to do this these kind of async calls Urbit natively with threads. And I think that would be a very, good place to potentially polish this thing later, would be to kind of import some of this into Urbit. But the point is that we're not exposing anything privacy-wise doing this. The the Bitcoin provider sees exactly the same information that it would. So I think it's a perfectly acceptable trade-off since this only has to be run by the provider to have this in an external program and write a thin wrapper like this with the option to upgrade it later. So that's a good example of something that probably should be native in the near future, but it can use prior work without any real problems. Things that have to be Urbit native, and actually this is something that took me a fair amount of time at the start of the project, is addresses. So we mentioned earlier that if you have this xpub, the seed for your public addresses, you can deterministically generate, a couple billion or 4.1 billion addresses for your wallet. The thing there is that you can't have your provider do that because in order for your provider to do that, you have to send it your seed, your xpub, and then from that point, they can know for the rest of time all the addresses that are associated with that wallet. And so what I had to do is go in, take the current libraries that derive addresses deterministically and port those into Urbit. And it'll probably get cleaned up at some point, but currently what that looks like is something like this is where it says base 32, which is Bitcoin current address format. And basically what I'm doing here, if you looked at the Bitcoin JS lib, this is basically just a direct translation port of that or the Python libraries. And then the kind of win at the end is that you can do things like take a public key and turn it into a Bitcoin address. Or any a lot of other operations like that. So, and same for PSBT partially signed Bitcoin transaction creation. Those also, in order to create those, you also have to potentially expose some of your wallet paths and xpubs. And so that also I've implemented it internally. The big thing here is that we want to have privacy upgrade paths. So by doing this internally, we keep two privacy upgrade paths. The simplest one is run a full node yourself, which would be like you just download the provider software for Urbit, run a full node, and then start going from there. And the other one is there's a lot of options for um, you could do a gossip protocol or something like that, which would basically let all of the clients of a provider gossip their address information requests among each other, so that when the provider finally got one of them, it wouldn't know who it was coming from, and even the clients, you could potentially make it so they don't know. And the key thing here is it probably isn't a great idea to design that right now until we know sort of how this will be used or the various threat models. But it's really critical to preserve that upgrade path, if only the really simple one right there. If we go on then to we're already talking about like sort of the benefits of running this JavaScript proxy versus chaining these commands together, these promises with Urbit threads. If providers were in every ship service that like everyone had to run, that would be like, I think you definitely would want to do that. It's way too burdensome to have people like piece together random, outside, even very small JavaScript services. But for the provider, we already have outside dependencies, and a provider is not in every ship service. So yeah, this is like a totally fine way to make that trade-off. From the client's perspective, nothing is different. Like even if we were using threads, they would be running on the provider anyway, and that would be totally abstracted from the client. So I think like a really good way to ask this is like, does this decision, when I'm like injecting an outside service into Urbit, do the clients know whether I implemented Urbit natively or not? And if the answer is yes, you're probably going to end up wanting to implement it Urbit natively. If only so that you have an easy install experience. But there's also privacy things where running it on your own Urbit lets you keep that away from the outside world. Before I go to wallet architecture, like anything there from the community or from your end, Lane or Josh?
We do have a couple of questions. Do you want to kind of pause and do a couple now, or do you want to save them for the end?
I think this would be. I think if there's anything like relevant we've done, this would be a good time before I go to like the client side wallet architecture.
I think Josh has one from the event series chat that could be good to discuss now.
Yeah, I do. And I have one of my own that might be good to talk about as well. But so going first, Palfan Foslip has a question, which is, would it ever make sense to have a Bitcoin vein and run a light/minimal node on Urbit natively, or does that throw all the principles you adhere to out the window?
No, I mean that like brings the principles I adhere to into the window. It would. I think it's like a great idea. I think the main obstacle now is just that like as everyone knows, Urbit has like the size limit of 2 gigabytes, so you wouldn't be able to put the node inside it. And then at that point, you're already going to be dealing with outside services, and so it's kind of boned. But once Urbit doesn't have that size limit, I think like that would make a lot of sense, and I think Hoon is like a fine, good language to implement like sort of a Bitcoin full node in. It would just be a substantial project, so my personal guess is that it's like a pretty long way off because of the fact that this isn't in every ship service. I guess what Palpat's getting at is that you could make it an every ship type service by making it run easily in Urbit, and so probably within 10 years we'll have that. Within 2 years we definitely won't. Within 5 years we may, is probably how I would put that. But I think it's something that should be kept in mind and is like actually, as hard drive space gets easier to deal with, I think it's actually like a pretty cool goal or thing to target.
Yeah, so Palfan was asking specifically about a light node, kind of like
I see. Yeah. Mm.
But
So the answer there is the thing I'm writing is already converging on being a light client. So yes, I'm going to have to go, like, it's pretty clear that I'm going to need to go ahead and write some kind of like block filters where like a new block comes and you can send to the provider like, some kind of filter that lets it know which addresses will be relevant to you, hopefully while preserving some privacy. So at
Yeah,
that point, we're getting very close to like client territory.
there's another follow-up question, which is one that I wrote down myself because I think what
Hmm.
begs is it's a question I've had, and ronreg-ribdev, captured it, which is, in general, how does one determine if a bit of functionality should be a vein or a user space app? And I think the idea here is that a vein is an I/O interface from the underlying machine into Urbit, and the consideration
Yeah.
that the vein needs to be, well, it will be subject to Kelvin versioning, and should provide some kind of, uh, uh, and I'm definitely not totally qualified to speak to this, so I would love it if
I mean,
there are
if you
any
look at the current, I
infrastructure
mean, probably someone else can say it
jump in
a
and jump
little
in.
better, but I think I can give a good enough answer, which is like, if you look at all the existing veins, like you have like Ames, Clay, Dill, Air, Iris, like they're all dealing with this issue of like, how do you provide like a clean layer between something in the outside world and Urbit?
Mhm.
Bitcoin is it's a really interesting like philosophical question as to like whether it is something in the outside world. It's very much on the line, but yeah, Ron Reg. The way to answer the question is like veins are like like an intentionally like limited set of interfaces to the outside world, and we actually hit on that briefly earlier when I said that the reason I wrote just like a proxy to go to elect RS is that it doesn't have direct like Urbit doesn't have ability to like send random TCP calls. The only thing it can do is HTTP, and that's like a conscious design decision to like limit sort of the outside surface of what you can have to interact with. So that's like only happening over Iris, those outgoing calls.
Awesome. Thank you for that. And then, we did have someone chime in Urbit, which is relevant to this conversation, from Master Morzad, which is that
Mm-hmm.
something should be a vein if it needs almost unmediated access to external events. And veins are more trusted than user space agents with respect to the Urbit namespace. Currently, only veins can implement fully referentially transparent actions to historical data. There's probably going to be more on that, but we can maybe
Yeah, you should tell me if like Joe is watching the stream so I can just like not say anything because his answers his
seems
answers will
like
be
he's
like
watching
way
the stream.
better on this topic. Yeah,
Yeah,
okay,
he
okay.
may
I'll
jump
just not.
in after the call in the meet. So if you
Cool. Yeah.
will, no promises there, but if he does, that would be a great conversation to have.
As a developer, I find this like super informational and super interesting. So I'm really happy people are making these points. I wanted to share from YouTube. So Ted Blackman said he doesn't think that any particular blockchain belongs in the kernel, but generic key storage and generation might want to live in the jail vein. Bitcoin integration
Yeah.
itself should not be in user space, but your keys and whatnot could be registered in the kernel along with various permissions. That's interesting.
Yeah, that's like a very cool long-term goal, which is essentially like an Urbit like pseudo hardware wallet where you kind of seal off your keys like in something like jail, and then you can just send things there to be signed either by Bitcoin or by anything. Yeah, that's like it's not doable right now for security reasons, but it's like a really cool goal to shoot for. That's probably on like a faster time frame than some like than you might think.
Cool.
Awesome. I have one more from my side. Dalton Collective asked, do you see Bitcoin and Urbit running through Lightning?
Oh yeah, like absolutely. In fact, like just like I'm gonna be talking. This is Christian set up like just like a talk with some of the Lightning developers just to figure out like exactly what that it would entail. But and we've also talked with Logan, like TechRite Socryp, about this. It's a really natural fit. It's just more work, so I just want to get this thing like working well, and we'll show where it's at. But yeah, I think that's like kind of inevitable in the sense that like we'll always want it and it will always be doable, so it'll end up happening.
Cool. Should we let's jump back into the presentation?
Sounds
Yeah,
good.
let's go here. So, okay, let's talk about the wallet architecture, because this is actually, most of what you're going to be seeing in the demo. And one of the coolest things about kind of packaging things up inside the provider is that most of my programming time is spent thinking about this once the Bitcoin stuff was implemented. So there's two aspects to the wallet architecture currently. There's push events from the provider, which is we subscribe to the provider's heartbeat, and it banes every 30 seconds, basically sets a timer every 30 seconds, and then put. Oh, I did, and I did not. So that's, yeah. Let me get that up there. Okay. Is that good? Great. So yeah, so we have like these, the subscriber pushes out a heartbeat every 30 seconds, which is just says whether I, the provider, have a connection to the Bitcoin full node, which could go down for a variety of reasons, like someone could trip over a power cord, network goes out, whatever. And so the provider just tells all its clients every 30 seconds, like, I'm connected or I'm not, and this is what the current block is. So all of the clients subscribe to that. And then there's pull, what I guess we could say are pull events, where the wallet itself requests like address info or transaction info, and also broadcast signed transactions. And biggest compliment to Arvo is that once I had that provider heartbeat working, and the provider basically being able to take information requests and then spit them back to the clients, I don't really think about the interface between the wallet and the provider that much. It sort of just works, and I'll show that, which probably means it will stop just working like as soon as I do. But let's see. Okay, and then in terms of what that looks like on the code side, and I can show this real quick. In your wallet hook, so there's a wallet hook and a wallet store. Basically, the hook is just sort of a mediating layer on top of um, on top of the store, and the store is more of like a data model in like the MVC type thing, whereas the hook is like the business logic. So what that looks like in practice, and this could be cleaned up some, but I think it's easy to see here, is that the wallet hook has a function that's handle provider update, where it'll take an update of the type of update from the Bitcoin provider. So we know what we have there, which is, as you can kind of guess, it looks like it's either some address info coming in from the provider, some transaction info, or like a raw transaction, meaning like just the hex of a transaction. This, by the way, is like a great example of something that could be implemented natively in Urbit, but it already exists in Bitcoin and it doesn't expose any extra information to the provider. So I just did it here for now, and then eventually this could be replaced without too much trouble by an Urbit native Bitcoin function that just generates the raw hex for a set of transaction inputs. And then the other thing it has is handle provider status, where we said the provider has a heartbeat, and so that's the status, which is the status type coming in. You could unify those types. I might do that in a cleanup. And the big thing here is we have, if the provider tells us that it's disconnected, we just update the provider in our state and say keep the same provider, but it's like the connectivity status is no, like not connected. And if it is connected, it has a set of logic that it runs through here in this block, which is documented here, which is essentially if there's any pending incoming payments to us, like basically another Urbit ship has told us I paid you and given us a transaction number. It basically sends all those transaction IDs to the provider to see if they're in the mempool, basically to see if the other ship's telling you the truth. And then if we find them, we can go ahead and take them out of our pending incoming payments and put them into our history. The same way that if you've used any kind of Bitcoin or Ethereum wallet, you like submit a transaction, nothing happens for a while, and then you see it's pending. That's basically this logic. If it's connected and it was previously disconnected, we go ahead and retry all of our address lookups, and we'll see that in a sec in the demo. And then if we found out that there's a new block, we have all these addresses that we're kind of monitoring, and we go and retry them and basically say, has anything new happened with them? That could 100%, anyone who's seen how light clients are implemented, that could definitely be optimized with like a Bloom filter or like a neutrino. And there's simpler ways to basically send the provider like pretty small data structure from which it can tell whether it has any information that's relevant to send to you. But for current purposes, in practice, this works totally fine. But that is like pretty high on the list of things to add. Okay, so let's go back to here. Any questions on that? We'll get into it. Okay. Let's actually go through now. This will probably take about somewhere like 3 to 6 minutes. Let's run through a demo. And what you're gonna be seeing in the demo is that, actually I should edit this because it should say, you're going to see like, we're gonna start up a provider. We're gonna connect to the provider from 2 ships. One of the ships will be the one that also is the provider. Like the provider can, use its own services, as we talked about. The provider will whitelist a client. The client will say, I want to add this like xpub, this seed as one of my wallets, and it'll figure out how much like money is on it. And then what we're going to do is we're going to make a payment from one ship to the other. And where that'll get to, I still need to implement the actual part where it broadcasts out, but that'll get us to the point where it generates the transaction that you would paste into Bridge or have pop up for your hardware wallet to sign. So let's run through that now and see what that looks like. First step is we need to start a provider. Okay, so we're right here, and I have a script that's like just to get a feel for like how much sort of surface area we're talking about. Sorry, this is really small. The rest will be bigger. Basically, this is about a 25-line bash script, maybe a little shorter, that starts up Bitcoin Core, electRS, and that node proxy that Urbit hits as the API to both electRS and Bitcoin. So I have a hard drive connected to my computer, like this guy right here, that has the full node synced. So we're gonna pop it up here. I actually can go and start doing the Urbit stuff while this is firing up, and it's gonna have to download a few blocks that happened while I was offline. Probably just maybe 5 or 10. So we can let that go in the background with no issue. And what we're looking at over here is I have, well, I'll start them up. I have two fake ships running. I have Zod and Dopzod. Okay, Zod is going to be the one that acts as the provider, and they both are going to be clients of Zod, meaning they're both going to have like their own wallets. And just what that what that looks like in the background, I have a script running that's copying the file, the code in there. You could also just do a one-time copy. So we have our two ships up here, and for Zod, let me pull up the stuff. Okay. So for Zod, we need to start the BTC provider agent. We also need to start wallet hook and wallet store, which are the wallet agents. So Zod is going to be a provider and also a client. So, hang on. There we go. Okay. So Zod went ahead and let me just do this. Okay, so it has all of those agents started now, and now we're going to go over on Zod. And what we're doing here is we're giving it credentials, basically telling it where to look for that API endpoint to find the Bitcoin full node locally. And this is exactly what you would be typing if you were running a full a full node. And then we're also going to tell Zod to set its provider to itself, meaning if its wallets need any information about the Bitcoin blockchain, ask Zod for them. And the program by default whitelists itself reasonably enough. So we run those two commands, and notice BTC provider, we added client Zod. On Dopzod, we just needed to start these two programs. And what we don't even need to worry yet about whether the provider is running, but we could actually check whether it's running here. And it is connected, meaning that it was able to successfully ping our full node, which is over here, and we can see that. So it's connected, successfully pinging it. So next thing is we're gonna try to connect to Zod from dopzod. We shouldn't be able to because Zod hasn't allowed us in any way. We're not part of some group or what have you. So we do this, and in fact, Zod tells us that it blocked it, and it tells us here we were kicked from it, so it's not able to. It doesn't maintain that subscription to Zod. So what we need to do is in the same way that we actually haven't done this yet. On Zod, we need to tell it to whitelist dopzod. If you're watching this and thinking that this would be better as a shoe interface, you're absolutely right, and that's on the roadmap. So now on dopzod, we can go ahead and basically say okay, give me set my provider to Zod, and now it does it, and we see on Zod that we added client dopzod as one of the clients. And actually, if we check the state again, it will actually see clients as the set of dopzod and Zod, and the whitelist is dopzod. Same thing here. We can go back to our wallet hook and basically ask it the state of its provider, which is that the host is Zod and it is connected, yes. We want to pay attention to that because that's not always the case. So what we're going to do now is simulate a loss of connectivity. Okay, so in fact, we're not just going to simulate it. We're going to actually create a loss of connectivity where we are no longer now connected to the Bitcoin blockchain. Zod in a second should throw out a ping and have it come back as not working. And we'll see a disconnected message here. Notice until then, it's still saying that it's connected, but that heartbeat should come in a few seconds. And if it didn't come yet and it sent it out, Zod would just throw an error, and then we would find it's not connected. So right here, we find out that we see that it's not connected. And if we look at that now, dopzod says we are not connected. Now, the nice thing here is that from sort of the perspective of Urbit ships, the connectivity is completely isolated to this interface where dopzod or any client or Zod just get to say, are we connected or not, and then can handle actions. And as soon as a message comes back saying that it is connected, we can, retry anything that we need to. So we've isolated it, all of the messiness of network connectivity in the outside world to just this right here. So we can go ahead and we can add a wallet while we're disconnected. And normally wallets need to scan the blockchain to figure out what their current state is. So we're gonna just add it right here. But what it'll do here is it'll try to do that, and we should see some some things go wrong. So basically, because it's not connected, it doesn't even try to send out a request to the network yet because it knows it won't get anything back. And so we could even look at this will be a really long list here, but we can look at the state of these are all its outstanding requests. Main thing to note here is just there's Bitcoin addresses in here that it's going to be querying, and as soon as it gets a message from the provider that it's back online, it's going to dump these all back to it. And if that yields any errors, it'll keep retrying them over time. So let's get back on the Bitcoin network by firing this up again. And again, this loss of connectivity could be any kind of error. It doesn't really matter. But they're all treated the same. I can't get responses without getting errors, or I just can't connect at all. So it's doing that right here. It'll go through a few things. And then what we'll see back here, once it's back, is it'll tell us it's back, and we'll see a flurry of messages as these requests, as dopzod gets the fact that it's back and then sends out a flurry of requests. So as soon as we can actually just watch here, we actually see Electrum RPC server running, which means we should be working. We have to wait until it that heartbeat comes here. So notice that it still says connected no. There it is. So the connected, now it got the message. One sec. That it is connected. And I'm going to explain what we're seeing here in these things. And now notice that we see, okay, scanned wallet, this ZPub. So it's fully scanned that wallet that we input, and it now knows its balance. Now let's look over here to see, this is on the provider side, the updates that it was sending back to dopzod. Notice that it goes through and scans a lot of addresses. Most of them have an empty, have no UTXOs and were never used. And so the wallet is going to record those as basically no one's ever seen these addresses. If someone wants to make me a payment, I'm totally fine to generate from this address, and then it internally will like increment an index and make this like, after this one, like this will be, the next one that it's fine to do. And then we do have like one address here that's used. It has a UTXO, meaning like something that can be spent, that has a value of 10,000 Satoshis, about $2. And then once the scanning continues for, I configured this when I back in this command for add wallet. We this thing right here is saying once you find eight blank addresses in a row, like then you're done. Okay, for both the change wallet and the main wallet. So once it found those, this like long string of no's, then the wallet knew that it was done. It stores that and it's scanned. And so now we can use it. We can do stuff like look for the balance, which is here's a scry into it for the balance of that wallet. We're doing it xpub p. It's just this xpub here I saved as a variable. So there it is, the 10,000, which is the one we saw come in there. That's how much money it has available to spend. About 1/10,000th, or exactly 1/10,000th of a Bitcoin. Key point here: the provider connectivity doesn't add mental overhead for the client. I think we saw here that like I can do lots of stuff to kind of like monkey around and break things. And it's pretty robust to that, because all it cares about is this yes, no, is the provider connected? And if it's not, all right, I'll just chill and send my information request later. So what we're going to do now is look at the process that you would do to pay another ship. And just like quickly to go over this, because I probably could have put a little more here on the presentation. A lot is going to happen behind the scenes here. What we're going to do first is we're going to add a wallet on Zod, a different wallet, so that Zod can have like its own addresses. So it'll go through here, and you'll see on the Zod side, you're going to see again a flurry of messages as Zod notice how it's getting information back from each of these addresses, which are actually, I'm pretty sure, all blank in this wallet. And then, or no, there's one that was used but done. There, and we've scanned the wallet, so now Zod has a wallet that it can use. And what we do then to pay, we can is Zod is going to poke Zod and say, I want to pay you 4,000 Satoshis. Send me an address. And Zod will automatically generate an address that's never been used. In fact, it'll be, if we could see into the wallet, it would be this one right here. It'll be the first in the queue. It'll internally increment its counter and say, if anyone else asks me to make a payment, use this address, not this one. It'll also put a watch on this address so that if anything happens with it in the future, we'll know. And yeah, pretty much that. And on the Dopzod side, Dopzod is going to, I'll show you. So here we go. Okay, a lot of stuff happened here. So notice that the provider sent 2 updates. Don't have to worry about exactly what those are. It's basically some transaction info. But basically what happened in the background here is Dopzod found UTXOs that had enough money to make this payment. It went ahead and asked Zod for it. Zod found an address and sent it back. And then based on that address and the UTXOs that were available to spend on Dopzod, Dopzod created a full transaction in this partially signed Bitcoin transaction format, which is kind of the standard for passing around, although I can easily generate others. And this is all, you can basically just take this base 64 and paste it into some code that's going to be merged into Bridge soon, and that would generate another transaction that can then be pasted back in here. Actually, interesting right here. Notice we have this thing where it says got new block, retrying 24 requests. All those addresses that we scanned earlier are being monitored in case anything happens with them. And if it does, we'll get that info and update the wallet. So this is way more verbose than like a final version would be, but this actually gives a good idea of a new block happened on Bitcoin, and that was pushed out from the provider to the client, which went to see if there's anything there. Again, there's a more efficient way to implement this, but the logic would stay pretty much the same. So this thing here, this data structure we're going to look at on Dopsod, this poem is it's like outgoing payments. So I'll go just quickly into, remember we wanted to make a 4,000 Satoshi payment? So here is the address that Zod sent back to us with 4,000. This is one of the outputs. Now we had 10,000 in that UTXO and you have to spend the whole thing. So it also generates another address, which is we can actually see right here. This is a change address. So the part I'm highlighting is it's at index one. It's in the change account. And notice its value is 3,140. That's because out of that 10,000, we also have to pay about, what is that, 1,860 as a fee. Okay. And then up here, we have, again, you don't have to, this is stuff it's better for computers to look at. But basically what this is here is a UTXO with the 10,000 value, which is where it's coming from. And all of this information is what generated our base 64 that can be signed, partially signed transaction. Now, this operation is, and actually, let's look really quick on the Zod side. That's incoming payments. It's a little simpler. All it has to know is I have an address that I gave out. Notice how these two addresses in the outputs for Dopsod and the inputs for Zod, or the incoming thing for Zod, are the same. And I'm expecting Dopsod to pay me 4,000 on it. So if it ever sees 4,000 Satoshis come in on this address, in its internal database, it'll update its history and say, not only did I get 4,000 Satoshis in this transaction, but I can attribute that to Zod, and any other agents I have running on my computer can depend on that, which is actually, for me, probably the coolest part of this whole thing, and the part I kind of want to explore the hardest in usage. This kind of like making Bitcoin information programmable from Urbit is a big deal. You can basically think of this as like an Urbit oracle that's negotiated by like the two sides of it. That's like very reliable. And then finally, this operation is like idempotent, so it does, like, I can do the same thing again, and it'll give me the same thing back. If I look back at that stuff, it's the same thing here. And I also can like change the amount, and it'll replace the earlier one. What I can do here is look at its thing here, and notice now it has the 3,000 transaction here, but it's still going to the same address on Zod because that one never got used. So there's not like an attack here where you can basically just spam Zod and keep getting tons of addresses. Zod's going to stubbornly give you back the same one to Dopsod until Dopsod actually makes a payment on it, and Zod sees that on the blockchain. And then again, yeah, that's actually. That's not good. So I need to make a note there on the change accounts that shouldn't have incremented. Okay. Now, you know what? Here's just for fun, just to see what it looks like, so that everything's not toy. I'll do like a few less. We can go in here and we can scan a real XPub. So this is like from one of my actual like Bitcoin wallets, and we're just going to go here. We'll put it onto Dopsod as a new wallet and let it rock. And what we're going to see is like there's a lot more addresses to be scanned. But because it's a real one that has activity, and people can like money dox me if they go through the YouTube thing and see everything here. But it's gonna go through here and it's just checking, and it's finding lots of addresses that have some unused data. And also notice there's a lot here that have no UTXOs, but they're used. So they previously had money on them, but then it was like sent out. So that's going to scan through all the way there, and then we'll check back in a bit. I could have changed the number to make this go faster, but it's going to go through a couple hundred addresses and then tell us here when that one's fully scanned, and we could check its balance as well, like with this command. I think that is it. So I have the Q&A stuff that Lane suggested earlier, but we definitely can open it up in general, and I'll let you guys know when that's scanned.
Tim, this was really awesome. We have a bunch of questions for you.
Seconded.
Okay, cool. Can you guys give me 1 sec? Let me just get some more water right here so that I can answer them without dying.
Welcome back, Josh. Yeah, lots of great community questions here.
I answered one of the community questions, which was, "What is Tim drinking?" So it's not whiskey.
Oh, yeah, no.
That's an impressive whiskey water fountain in the background there. Then.
Right?
Oh, yeah. Like, oh, yeah. No. So right now it's hot water, but this was like Georgian wine.
Georgian wine. That's impressive.
Yeah, I wanted to get like a little tanked up before the episode.
Awesome.
So
Another,
next,
couple of serious questions. Will you post your wallpaper in Urbit somewhere?
this is no so Ravnus actually noted this earlier when I had it somewhere else, but this is Thomas Cole, like whatever the fall of empire or something. So it's like here it's this is actually a nice thing on like workflow. So I basically do like just like here. Let me one sec. Let me pull something up right here to show. But search for Thomas Cole. What is it's like a series where it's like the one that I usually have up is like Desolation because it fits the brand, but basically you just go through like the progression of civilization through like early man to kind of Arcadian life to like flourishing and then like raping and pillaging, and then there's like a final one where you have the ruins of it. But search for Thomas Cole.
Do you switch to different desktops depending on your mood, like how constructive or destructive you're feeling?
As with anything else, like it all like kind of like you become numb to everything. So I just associate them with what's there. Like my browser is always on the destruction one, like Bitcoin, and this is not like symbolic, but is always running on the flourishing civilization. And then Emacs is here, and like all my terminals are here. Yeah.
Cool, Lane. I'll let you.
Well, so we are past an hour already. We can certainly do some Q&A. We can also kind of just go and open things up. I don't know. Do either of you guys have a thought or a preference?
I think it more depends on the community at this point. I'm just looking at like the questions. I don't think there's only like the only thing I would want to talk about or have people think about is just like thinking about like prior Urbit coding experience that I didn't have. Which probably shows in like parts of this, but also like I want people to like get an idea of like the barrier to making like contributions isn't that hard, and one of the best things Josh is doing right now is like organizing where the best places to direct energy are. So I mean, I didn't come up with this project. He came to me with it like pretty fully formed, and of course there were a lot of implementation decisions after that, but like I mean that saved significant time, and I think we have all like other things like this in the pipeline that like expand on some of this type of stuff. And so if people have like ability and interest, there's like definitely room to do it, especially like for bounties and stars and stuff. But big point, you don't have to make a bounty or like come up with an idea. We have like probably another like couple years worth of like ideas and work to move forward with on like urban infrastructure.
Yeah, just a little plug there. We've been keeping a notebook in Urbit community called Project Ideas. If you're not part of that, there's a constant stream of fun little things, sometimes bigger things that are flowing into that. If you're looking for something to do and want to contribute, the best way to learn the stack is by picking a thing and doing it. You will figure it out, and there are people that will help you.
Yeah, pretty much that. So yeah, let's go. I mean, if you have any like questions that you want to hit, or else I'm fine to like throw it just to people here, and then we can go to open.
Yeah, let's do a couple quick ones, and then we can end the stream and switch to the open format. One question from John Lester is, how easy would it be in the future to add support for other Bitcoin forks like Ravencoin, Dogecoin, etc.?
Not that hard, but I'll probably like actively try to like destroy your repo or like submit bad stuff on it. So it's like easy from a code perspective, but I think it'll be hard from like a social engineering perspective because of the anger it'll generate.
Oh, Dogecoin doesn't make anyone angry. I can't speak to other coins,
That's
but
true. That's true. I'm going for more of a like really like sort of like, modern Catholicism. This is like Sharia law, Bitcoin maximalism. So stuff has to be.
Yeah, it's funny. The topic of religion keeps coming up in the context of both Urbit and Bitcoin. Maybe we can. I was hoping to talk about that on the stream, but maybe we'll save that for the happy hour.
Yeah, I mean,
format.
it's worth talking about briefly, because I think doing this project gave me a better appreciation for what can be done with Bitcoin. Its primitives are really good, and I always liked it as like kind of just its normally known like monetary properties, but it's even just from a programming perspective, it's really bare bones, but it's quite nice, and there's a lot of cool things you can do that I think we're even just starting to explore now as more money ends up being stored there.
Totally makes sense. I have one final technical question from the community. So L Champion asked, if you create two separate transactions without submitting either of them, is there a chance that the UTXOs used in the transactions will overlap?
Yeah, that's a great question. And actually, I've been thinking about this a lot from a design perspective. What I've done currently, because it makes the most sense, is when you submit, like, if you try to create a second transaction, it's just going to bump your current one out of there, because there's really, if a use case comes up where a user needs to be making tons of simultaneous payments, we can look at that, and there's ways to handle that. But yeah, it just bumps it out of there, and it won't even let you, unless you really kind of jigger it yourself. It won't let you even do that until those UTXOs have been used, or it sees them out there.
I was curious, does the provider wait for some number of confirmations before assuming a transaction has been processed, or is it happy once it hits the mempool?
This is a great question, because it actually highlights the fact that the provider in this model is completely dumb and stateless. Okay, completely. The provider maintains no state information about the client. It just gets these requests with associated IDs, so that when the client gets them back, it can piece together stuff as necessary. But it does not handle anything related to confirmations, and the clients are completely responsible for managing all of that. In practice, the way that looks is that you, on the client side, there's like a few options you can configure. But there is a difference between how it handles something that, like, if another ship tells you about a transaction and said, here's this transaction with this ID, and it's not in the mempool, we don't kind of clear them and start giving them new addresses yet if they try to make payments. It'll wait till it actually sees that in the mempool. And then everything after that is, I think, pretty well trodden territory with a lot of prior art, which is, you tell people how many confirmations there are, they can decide how many they're comfortable with or have it as a configuration in the software. But that part is pretty straightforward.
Follow-up question from the Urbit community. Could this lead to having Bitcoin mixers in Urbit?
Oh, good. I mean, probably. That's like a substantial, like, to do the non-centralized version of it, like CoinJoin type, like, it's like a substantial amount of work. So yeah, you probably could do it and coordinate it between ships in that way. But cost aside, just because of implementation network effects, I'm not sure why you wouldn't just use like Wasabi. But yeah, short answer, you could do it, and a centralized version of it would be like pretty trivial. But I think for legal reasons, it's like a bad idea to run your own centralized mixer. So I'm like, that falls under the category of like, you're going to have a bad time most likely, unless you're in a good jurisdiction.
Cool. Should we open this up?
Yeah, sure. If you have no more questions from your end, sounds good to me.
Yeah, let's do it. So I guess you stop recording.
Let me throw one little one at you too. I think this is probably something we can get through. Does this count transaction value accumulatively? Like, in other words, for the 4,000 sats, could I send 2 transactions of 2,000?
Yeah, that's a good question. And actually, that's essentially what I'm trying to do. And I think I said earlier is like build payment primitives for Urbit, and then of course like expand on my own primitives later and recombine them, and have other people do that. But the idea here is just to make a primitive of this happened from this person. So the answer to your question is if both those transactions came in, like, you know, a 2,500 and a 1,500, and you see they're both from like Gimblep Floploop, like you can then go and like have your software say if two things happen within a certain period of time, or since I saw anything from this person. It's essentially just a database query where you're joining them together. So short answer, absolutely, and I actually kind of anticipate stuff like that happening.
Cool.
Awesome. Tim, thank you. This was fantastic. I learned so much. You know, it's really exciting to hear about the intersection of two projects that I'm also very excited and passionate about. I'm sure you feel similarly.
Yeah.
This has been great.
Hopefully people just get an idea of like how like cool the batteries included stuff in Urbit is. And I know with like Palpin's one that was also there as well, but the only thing I didn't really mention in this aside from like the batteries included part being nice is that refactoring was like pretty pleasant, and I had to do a lot of substantial refactors because I hadn't done much Bitcoin programming at all coming into this, and so there were a lot of things where I would just end up with a completely different mental model, and that'll happen. But Hoon is like good enough in that regard that you can get through pretty big refactors just by like, you know, monkeying away and then seeing if it compiles. So I would just encourage people there as well.
Awesome. That's good to know.
All right,
cool.
All right.
Yeah, so just a reminder to anyone who's watching the stream, we're going to open up and switch to like a happy hour format. So we will drop the link for this event in both YouTube. I guess, Josh, you could drop it in YouTube, because I can't do that, and I can drop it in Urbit community. Yeah, and then so I think this is our last call for this year, but we'll be back, I don't know, second week of January, something like that for one next year. And as always, if you're interested in presenting, if you want to nominate someone else to present, if you want to help out, reach out. We can use all the help we can get. So happy new era, and I guess happy new year as well.
Yeah, happy new year, everyone.
All right, Josh, you could leave the stream up for a moment. I'm just going to switch it off
Okay.
here.
And then how does it